Hi, 7th grade. Welcome to lesson 4.4, Expand Expressions. By the end of the lesson, I want you to be able to say, I can expand expressions using the distributive property. Solve and discuss it. The school is planning to add a weight room to the gym. If the total area of the gym and weight room should stay under 5,500 square feet, what is one possible length for the new room? Show your work. Are there other lengths that would work? Why or why not? Okay, what is the relationship between the areas of the gym and the weight room? So we know that the weight room has to be at least 55 inches long. But we don't know how wide it should be. So we could plug in numbers for X. Maybe we say 10. The whole gym and the weight room would be 55 feet long and 100 feet wide. If we multiply those together, we would get 5,500. And it said it should stay under 5,500 square feet. So the weight room should just be less than 10 feet. Focus on math practices. What is an expression using X that represents the total area of the gym and the weight room? So area equals length times width. Area equals, well, we know our length is 55. And our width is 90 for the gym plus X for the weight room. Example 1. Expand using the distributive property. A family farm plans to add a blueberry patch at the end of their apple orchard. What is the total area of land that will be covered by the blueberry patch and the apple orchard? So we know that the width of the apple orchard and the blueberry patch is 1.5 kilometers. We don't know the length of the blueberry patch, but we do know the length of the apple orchard is 2.5. So what we are going to do is length times width. So here's our length, and b plus 2.5 is our width. So we're going to distribute. Remember, distribute means to multiply. Distribute, multiply. So 1.5 times b is 1.5b. 1.5 times 2.5 gives us 3.75. So the expression that represents the total land area is 1.5b plus 3.75. Try it. What is the expanded form of the expression 3.6 t plus 5? Whenever I see that number outside of the parentheses, I know I'm going to distribute. I'm multiplying. So I have to do 3.6 times t and 3.6 times 5. So 3.6 times t gives me 3.6t, and 3.6 times 5, I believe, is 18. Let's check our calculator. It is 18. So the expanded expression is 3.6t plus 18. Can't go any further because one of them has a variable and one of them is just a constant, so we cannot combine them. With our area model here, 3.6 is the length, t is the width of just whatever that part is, and then this must be 5. This fills in as 3.6t, so you can see it visually. Convince me, if you know the value of t, would the evaluated expression be different if you added the known value of t and 5 and then multiplied by 3.6? So they're saying, okay, say we have t equals 3. Would it change if we did, so we plug in 3, and they're saying, would it be different if we added the value of t and 5 first? So 3.5, 3 plus 5 is 8. So now we do 3.6 times 8 gives us a total of 28.8. Is that any different than if we did the distributing. So we distribute in 3.6 times 3, which is 10.8, and then 3.6 times 5, which is 18, and then added. Is there any difference? No, there's no difference because they are both equivalent expressions. This expression and this expression are equivalent. So they give me the same answer. No, because the expressions are equal. All right, example number 2. Expand expressions with a variable. Use the distributive property to expand the expression. Okay, so I have a variable on the outside of the parentheses. It needs to be multiplied to everything inside the parentheses. So we do x times negative 2 and x times negative 0.5y. X times negative 2 is just negative 2x. X times negative 0.5y is just negative 0.5xy. So that's our expression. Nothing we can simplify because they have different variables. When it comes to having more than one variable in your expression, that is okay. It is just better practice to have the variables written in alphabetical order. So you could have written it 0.5yx, but it's just better practice to have them alphabetical. So let's try it. Expand the expression t times negative 1.2w plus 3. So I'm going to distribute my t into everything inside the parentheses. So we do t times negative 1.2w plus t times 3. T times negative 1.2w equals negative 1.2 tw plus 3t. Same thing. It's best to have the number first, then the variable. Last example, expand more complex expressions. So simplify the expression. One way is to use the distributive property first, so multiplying the 1/3 into everything. 1/3 times 2, well, remember you could put 2 over 1. That's negative 2/3. Again here, put 3 over 1, that's 3 over 3, which is 1 whole. And a negative times a negative gives me positive. Same thing here, but a negative times a positive gives me a positive. Negative times a positive gives me a negative. And then, once you have this expression, you can see we have like terms to combine. So we have negative 2/3 and negative 1 combines to negative 5/3, and you just bring the x down. The other way is to simplify within the parentheses first, then distribute. So we can see that we've got a positive 2 and a positive 3. That adds together to get 5. Then they take the distributing step. So 1/3 times 5, put 5 over 1. Negative 1/3 times negative 3, put negative 3 over 1. Multiply through, and we get the same expression. So either way, it doesn't matter. So we can try both ways here. First way was to distribute first. Okay, so I'm going to distribute negative 2/5 times 10 plus negative 2/5 times 15m. I'm going to erase this into myself rough room. Minus 2/3 times negative 20n. Okay, negative 2/5. Okay, I'm going to put this over 1. Negative 2 times 10 is negative 20. 5 times 1 is 5. Negative 2 times 15, I'll put this over 1, gives me negative 30. 5 times 1 is 5. The m comes along. Negative 2 times negative 20 gives me positive 40. 5 times 1 is 5. Bring along the n. Now we'll simplify. Negative 20 divided by 5 is negative 4. Negative 30 divided by 5 is negative 6. Bring down the n. Positive 40 divided by 5 is 8. Bring down the n. Can I simplify this any further? Nope. All right, 7th grade, let's say it. I can expand expressions using the distributive property. Have a great day.